together. So from here, when we have this as b over a to the power of n, this always equals as b to the power of n over a to the power of n. So applying it here, we are going to have this as m to the power of 3 over 2 to the power of 3 equals 8 over 1. Cross multiply. So here will be m to the power of 3 equals 2 to the power of 3 times 8. So we have m to the power of 3. Then 2 to the power of 3. This will give us, we can have this as 2 to the power of 3 as 8 times 8. Now from here, we have m to the power of 3 that equals 8 times 8. And this equals 64. So we have m to the power of 3 equals, we can have 64 as 4 to the power of 3. And if you have this as 4 to the power of 3, let's have it as m to the power of 3 minus, taking this one here, 4 to the power of 3, then let's have it to be 0. We can now solve this as algebra when we have a to the power of 3 minus b to the power of 3. We call this difference of 2 cube, and this equals as a minus b, in parentheses as we have it here, times a square plus ab plus b square. Now, applying it here, we will discover that our a equals m, then our b equals 4. So we are going to have here to be m minus 4 times m square plus m times 4 here will be 4m, here will be 4 square. We have to close them. Mind you that equals 0. So here will be m minus 4 times m square plus 4m. 4 square will be 16 equals 0. Now again, from 0 product rule, is either we have m minus 4 in parentheses equals 0, or we have m square plus 4m plus 16 all in parentheses equals 0. Now let's define them separately as case 1. Let's define this as case 2. So from here we have m minus 4 equals 0. Taking this, add 4 to both sides of this expression. So we're going to have m minus 4 plus 4 equals 0 plus 4. So let's cancel out this. We have m to be equals 4. That is the first solution. Now, considering the second solution, we have m squared plus 4m plus 16 equals 0. Recall that let's define the following parameter: a to be the coefficient of m squared 1, b the coefficient of m is 4, then c to be equals 16. Then we have m to be equals positive or negative, minus b, positive or negative, square root of b squared minus 4ac over 2a. So we have m equals, b is 4, we have here to be minus 4, positive or negative. Here will be 16 minus 4 times a is 4 times 16 again over 2. So we have m minus 4 positive or negative root of factor 16. Here will be 1 minus 4 over 2. Then we have m minus 4 positive or negative 16 times minus 3 over 2. So this will be m equals minus 4 positive or negative root of 16 times root of 3. Root of minus 1 is going to be I in a complex mix over 2. We have m minus 4 positive or negative 4, which is root 16 multiplied by root 3i over 2 over 2. So from here, our m simply equals minus 2 positive or negative 2 multiplied by root 3i. And of course, this is a complex solution. Complex solution. So why this one is the real solution? So one can check. We are given m over 2 in parentheses to the power of 3. It's going to give us 8. And m equals 4. So we're going to have here to be 4 over 2 parentheses to the power of 3. It's going to give us 8. 4 divided by 2 will be 2 to the power of 3, which equals 8. So 8 equals 8. You can see that the left hand side equals to the right hand side. And so therefore, we can declare finally that this is correct. But checking for the complex solution, I think one we have to be very careful.